Okay, today we're going to have a look at how we can represent information from generally experimental probabilities in two different ways. One is using a Venn diagram, which is that, and another one is using a two-way table. Now, the information in both the Venn diagram and the two-way table is the same. They are just two different ways of representing, and after we represent the Venn diagram, the information in a Venn diagram and in a two-way table, then from that we can calculate probabilities. Now, important thing to note is, so for example, for this one, is that we're talking about two different incidences, or we're talking about two different events, where for this example, it gives us information about people who own computers and what type of computers they own, and it's owned by 100 people. So the things to note in this is that the way to read that is, if I have to ask you how many people own PCs, so the total number of people who own PCs is, you go to PCs and go right across, and you see there's 62 people who own PCs. The total number of people who do not own a Mac, so no Mac, you go down to Mac, keep going down to the total, and the total number who do not own a Mac is 57. Likewise, the number of people who own both a PC and a Mac, so that means both a PC and a Mac, they coincide over there. Now, and this number 12 would match with that 12, which is where our intersection is. So that 12, both who own both PC and a Mac, corresponds to the intersection on our Venn diagram. So it's very important to note where some of these information are. So people who don't own no Mac and no PC, 7 of them. Actually, I should use a different color. 7 of them, and this 7, if you see, is outside our two circles, or in the Venn diagram, outside, but within the set. Okay. Again, the other things to take note are the totals. So people who own a Mac but no PC is 31. So 31 is over there, and then people who own a PC but no Mac is 50, which is over there. So I hope that makes sense. We'll have a look at an example. Now, from this, then the next thing to look for is, if you have to calculate probabilities, then that again is based on the information that's given over here. So, for example, if you have a look at just these probabilities over here, the probability that people own only a Mac, so only a Mac is 31, and that's 31 out of a total of 100. Okay, we'll have a look at an example. So if you have a look at this example, from 50 desserts served at a restaurant one evening, 25 were served with ice cream, 21 were served with cream, and 5 were served with both cream and ice cream. So what you need to do is to illustrate this information using a two-way table and a Venn diagram, so two different ways, and then answer the questions of the following questions. Now, we'll do the diagram first. We'll do the table and the diagram first, and then we'll move on to answer these questions. So let's do the first thing, which is the two-way table. Okay, so that's part A. Important thing to note is, first, what are the two events? So the two things are that people were served with either ice cream or served with cream. Okay, so I'm going to use I for ice cream and C for cream. Okay, and we'll do that on our table. So the two things that we had was I for ice cream. So people either had ice cream or people didn't have any ice cream. People either had cream or people did not have any cream. And then we also have the totals column. Likewise, we have the same for ice cream as well. Okay. Right, let's just complete that. And that's the total over there. Now, to put all of this information in the table. So it said that from 50 desserts served at a restaurant one evening, this tells us that the total over here should be 50. Let's look at the next one. 25 were served with ice cream. So 25 of them had ice cream. So if we go to our total of 25, this should be over there. And 21 were served with cream. So then go to cream. The total of that were 21. Another piece of information which is important says that 5 were served with both cream and ice cream. So cream and ice cream, this is supposed to be 5. And from here now we work backwards and fill in the gaps. So basically 5 plus something gives us 25, or 25 take away 5 is 20. So that means that the people who had desserts, 5 of them had both cream and ice cream, and 20 of them had no cream, but they had ice cream. So therefore the total number of people who had ice cream were 25. Likewise, we'll go backwards. 21 take away 5 is 16. Over here, 50 take away 25 is 25. Then 25 take away 16 is 9. And 20 plus 9 is 29. What we need to take note of is if you add that way, gives us a total of 50. If you add across, gives us a total of 50. Okay, now let's put the same information into a Venn diagram. So in a Venn diagram, we basically would have our that's our Venn diagram, and we have the 2 events, so therefore 2 circles. Okay, that's for ice cream and that's for cream. And let's start filling them in. Easy thing to start off with is the intersection. So both ice cream and cream is 5. So therefore the 5 would go in the intersection. Okay. No cream and no ice cream is the 9. So 9 would go outside in neither of the circles. Then people who had ice cream, so the number of people who had ice cream, so 5 of them are in the intersection, but they didn't have the cream, so 20 will go over there. And likewise, the number of people who had cream, 5 of them were in the intersection, so 16 will go there. Now, the way to check is if you add all of these numbers, 20 plus 5 plus 16 plus 9, it should give us a total of 50, because 50 people were served. Okay, now let's go and do the questions. So, question, the first one, how many of the desserts did not have cream? So no cream at all. So did not have any cream, which is a total of 29. So the first, so part B, 1. How many of the desserts did not have cream? So no cream is 29. How many of the desserts had neither cream nor ice cream? So no cream, no ice cream, and that is 9. Now the next part is where you have to find the probability. Find the probability that a chosen dessert had cream. So probability of a cream is equal to however many people had the cream. So probability of having a cream is a total of 21. Divide by the full total, which is 50. Okay. Probability of only a cream. So not just cream, only cream. So only cream. So that means you go to only cream, which was only 5. So no ice cream. They only had the cream. The other way to look at it is you can either look at it from the table or from your Venn diagram. So only cream is only 16 of them with a total of 50, and you can simplify that to 8/25. And the third one, the probability that they had cream or ice cream. So that means everything inside the two circles, 25 plus 16 gives us, so let me write that down, probability of cream or ice cream. That means they had either the ice cream or the cream, and that would be equal to 41/50. Okay, now this cream or ice cream, this now takes us to the next part, which is set notation. Now set notation is where we actually talk about our Venn diagram, so all the information, all the events, and we use specific language. Now, very important to note all of these different vocabulary. So a subset is represented by that sign, like a C. The sample space is basically everything that, all the outcomes, so all the outcomes that you can get. A complement means everything apart from A, so everything outside A. That means that 5 is a set, is in the set A, so 5 is an element of A. Null or empty, there's nothing. This means the number of elements that are in A. Now the next thing, which is very important, and I'm going to relate that to the example that we've done, is A intersection B, which means A and B, which would be 3 in that example. Then a union B, or A or B, means everything in set A and everything in set B. Hope that makes sense. So if we go back to this example, of ice cream and cream, then basically I intersection C is equal to 5, which means, and I'm just going to highlight that, so that 5 and that 5. Another way of saying I intersection C is I and C. That's another way. Instead of intersection, if you want to say I U C, which means I or C. So that means everything in set I and everything in set C are all of these numbers, 25 and 16. If you add them all together, so 20 plus 5 plus 16 is equal to 41, which is exactly what that is. Okay.